class, it's all guys, isn't it? All right, yeah. But today we're going to talk about, I was going to talk about, Thomas Liner was going to talk about combustion, what works a piston, so she was gracious enough to bring us a cylinder head. When I was looking over this last night, I was like, I don't change course. We'll come back and talk about combustion of an engine. We're going to talk about something that you're probably already familiar with, and that is propellers, or props, as their slang term is. We're going to talk about propellers, and how propellers are designed, and how they actually produce thrust to make them go. So, my name is Mr. Walker. What the propeller is a rotating airfoil held in place by a hub. Now, what exactly does that mean, a rotating airfoil? We talked about lift the other day, and the wing creating lift because the wing has an airfoil. Remember talking about that, about Pirelli's principles of pressure, low pressure, high pressure, because of the airfoil. So the prop has the same aerodynamics factor. It has an airfoil. This wing, this prop has got a little bit of an airfoil about it. The back of the prop is actually flat. So on a real aircraft, the prop is flat, and the top has a little bit of curvature on it. So propeller is a rotating airfoil. So this is the airfoil, and it's centered around the hub. So this is just like a wing that, instead of going straight like a wing of aircraft, it actually turns around this hub. So just like I said, it's just like a wing, except a wing doesn't provide thrust. This prop actually provides the thrust. The wing would provide lift, this would provide thrust. So that's what we're going to talk about today, is a fixed pitch prop. And then we're going to talk about thrust. How does it provide thrust? Well, the first thing we'll talk about is the shape of the airfoil. So this will be our hub. We have a hub, and I've got this out the side. And so from there, I want you to notice about the prop, it's twisted. See how it's twisted? It's got an airfoil to it, but it's twisted. So up here close to the hub, remember the back side of this prop is flat. And then the tip, the back side is flat. Here's the airfoil. And then the tip, the airfoil is like that. So if we go down this prop, less flat. So it's kind of tapered off. This prop is twisted close to the hub. The airfoil is big and dynamic toward the tip. It's almost flat. When you get out here, it's real thin, it's real flat toward the tip. So we get thrust by the shape of the airfoil. Another way we get thrust from a prop, not only the shape of the airfoil, but something called the angle of attack. Remember the angle of attack, we talked about a wing, and the angle of attack was the wing was flying along and the relative wind was coming at it. But in a prop, a little bit different dynamic. A lot of stuff on what you see in my diagram, that's supposed to be the side of a prop. You're looking at it like the prop on an airplane. You have relative wind. I'm showing the wind coming from the bottom. You have the attack of this, the pitch of this prop. You say, well, wind doesn't come from the bottom. Well, you think about the prop is slicing the wind. So the wind is vertical to the prop, so it's slicing the wind. And this angle between this pitch of this prop and the wind is what this angle of attack is. And so it's really important. You can have props that have a different pitch on their props. This is a fixed pitch prop. They use that for smaller aircrafts. When you get to larger aircrafts, they actually have pitches that will turn, and they're called variable pitch props. And we'll talk about that maybe at a later time. But actually this pitch that you see here will actually, while you're flying, you can turn it. You can flatten it out, or you can get a bigger bite. So as you're biting into the wind, you can change your pitch. And also talking about pitch, there's props designed. There's two times when you're flying. One is climbing. You want to climb. You want to take a bite out of the air to climb, and then another when you're cruising, you're flying level. So when you're flying level, you want to take a bigger bite. So you want a bigger pitch to grab more air. It's like a big screw. You just want to grab a lot of air when you're cruising. When you're climbing, you want to have some high RPMs. You want to be spinning that prop as fast as you can, and the prop's going to be a little bit flatter toward the tips as you're climbing. And then when you cruise, you want to take big bites, a lot of power. So this being a fixed pitch prop, only has one pitch on it. And, so that's called the angle of attack. Alright, so we've got two things covered. We've got the shape of the airfoil, which is the airfoil on the prop. Then we have angle of attack, which is the pitch. What do you think the third factor is to make this prop actually go?
The engine.
The engine. You gotta have an engine, and the engine does what to the prop? Yeah, you got to make it spin, because we can sit here all day long, that's going to happen, but when you start spinning this prop, then you create thrust. So our third one, we'll abbreviate, RPM stands for what? Revolution per minute. So we'll spin this prop up, and that's when we create thrust. So the design of the prop being the airfoil and the pitch, and now we have the revolutions of the prop to make it go fast. So we're not go fast. So if I have a prop here, it's like a mustache of a prop. There's my prop. And now we're going to have circles. Which way does that prop turn? Anybody know?
No, it's not.
I'll go with clockwise. Right? I'll do that. Imagine the prop, imagine it going clockwise. Yeah, this one goes clockwise, see it's taking a bite out of it and it goes clockwise. So, my airplane, I'll spin my prop up when I'm cruising, the RPMs of my airplane. It's 2,300. 2,300 revolutions per minute. So my airplane, when I'm cruising at 2,300 revolutions per minute. So that prop is moving really fast. That motor's moving fast. So with that motor going that fast, I want you to think about something. When the motor goes 2,300 feet a minute, the tip of that motor, how far does it travel? This tip. Not much. It sits right there and travels that far. How far does the outer tip travel? Which is traveling further? The hub of this motor travel further, or the tip travel further? Yeah, obviously the tip's traveling so much further, and since it's traveling further, is it faster or slower? Which? Yeah, it's faster than the hub, because this is traveling that far, and this hub is traveling just right here. So you think about traveling. So when my airplane is cruising at 2,300 RPMs, let me give some dimensions to this. I'm going to call this 20 inches. I'm putting the size, the length, to give you some idea. I'll explain this to you anyway. My prop is 60 inches long. 60 inches long. We're going to section it up. 20 inches, 40 inches, and 60 inches from the tip to tip is 60 inches long. So as my prop is moving at 2,300 RPMs, this inner 20 inches, it's moving along pretty fast. The inner 20 inches is moving 129 knots. That's how fast that inside that prop is going, 129 knots. So my shaft, my motor is 2,300 RPMs. First 20 inches is 29 knots. What about the next 40 inches? You think it's going faster or slower or staying the same? Faster. How much faster? How about double? The next 40 inches is 259 knots, so it's going twice as fast. Yeah. It's going twice as fast. What about the outside tip? You think it's going faster, slower, about the same? Yeah, it's even going faster. The outside tip of that is almost 400 knots, 389 knots, the outside tip of that. So we got a prop. The inside's doing 129. 2/3 of the way is doing 259. The outside tip is 389. Now that explains why there's a twist on this prop. Notice the twist. All props have a twist. The backside is flat. The top has an airfoil, but it's got a twist. So, which is going faster? Is this inside going faster or the outside going faster? The outside's going faster, so it's almost flat. Well, this prop is almost flat. It's just getting a little bit of a bite. Because this is going really fast. The inside has got a big old pitch on that. It's not going near as fast. But as this goes through the air, it all equals out. The tip has just as much thrust as the inside does. Why does the tip have just as much thrust as the inside? Because it's moving faster. It's cutting through more wind. It's cutting through more air. It's covering more air The inside has just got this much air, and the outside has got this much air. So, yeah, very good. Shape of the airfoil, the angle of attack, and the RPMs. And finally, when you look at a prop, my prop has got a number. My prop for my airplane, they call it a 60-48. What do you think 60 means for my prop for my airplane? What does 60 mean on my airplane? How long it is? 60 inches long, yeah. What do you think 48 means on my airplane? Well, 60 is the length of the prop, 60 inches. If I were to turn this prop one revolution in air, it's going to travel that far. One revolution, that far. 48 is, I'm going to travel 48 inches for one revolution. One revolution, 48 inches. So 60-inch prop will travel 48 inches every time you turn one revolution. All right, this prop I got in my hand. What's the bottom number right there? Okay. Gave me a number of this prop I have in my hand is a 19/8 prop. 19/8 prop. So what does that mean? What's 19 mean? Yeah. Got a 12-inch ruler. Measure down 12 inches, measure down about 7 inches. I got 19 inch prop. Good. What does 8 mean? One, yeah. Well, you guys are so much smarter than these other guys are. I'm telling you. One revolution, 8 inches. So if I add 8 inches on this ruler, you go one revolution, 8 inches. 8-inch prop. So I got a 19/8 prop, 19 inches, 8 inches revolution. So that covers everything. How do you get thrust, shape of the airfoil, the angle of attack, and the RPMs. Questions?
Is it going that fast? Like, is it traveling 8 inches per rotation at 2,300 RPM? Like, is it only doing that for cruising altitude, or is it for any speed?
That's a great question. It's really for any speed. That kind of gives me how much this pitch is and how much this airfoil is. And it's like, if I go slow, it should cut through the air that much. Theoretically, it should be at any speed, but I know if I'm moving it slow, it's not going to do anything. But there is another element that we're not talking about, which is called slip and drag, which is a whole different lesson, slip and drag. So we can sit there idle with our prop going like this, and are we moving? Or aren't we moving? Because I got a big old hunk of an airplane sitting over here that's got a lot of drag. But at some point, we get it to speed fast enough, it's going to overcome the drag, and the airplane's going to start moving. In a perfect world, if there wasn't any drag, there wasn't an airplane back there, as soon as you turn that, it would start moving. So, great question, but there's at some speed, and whenever it gets fast enough, it's going to start overcoming the drag of the airplane and the weight of the airplane. But when they design them to say, okay, we're going to travel 8 inches one revolution. Now, in reality, it's not going to travel 8 inches one revolution. That's just the way that propeller's designed. So, but you got to overcome slip and drag. The slip is, while you're spinning it up real fast, we may not really go 8 inches. So, yeah, drag. Drag is really important, and we'll have a lesson on drag, induced drag, in the way of the aircraft. So, absolutely correct. Good answer, good question. Yeah. Anything else? That's all I got on prompts.
Any
Big
questions?
six prompt.
Y'all good? Understand it? Awesome, awesome. Thank you, Mr. Walker. Thank